Hello dear friends. Now we will see that the examples of collision and the relation between the initial velocity and the final velocity. That means we will find the initial and final velocity relations in term of collision in one dimension and in two dimension. So first of all we will consider that let's consider the completely inelastic collision. So our first case that we will start, that is completely inelastic collision. So it is very clear that if it is completely inelastic collision and that is also in one dimension, so we can say that theta 1 is equals to theta 2 is equals to 0. So we can say that suppose one object is lying here on the ground, another object is also lying on the ground. Now initially we consider that only object 1 is moving while object 2 is supposed stationary. Now it comes and collide with it. So it is very clear that m1 vi, that is velocity of object 1, and that initially this v2 will be 0. So we can say that this v1 is only existing, and therefore as per as momentum conservation law we can say that initially only m1 vi is the velocity of object 1, or we can say that it is m1 vi. So I can say that it is m1 vi. Now obviously this is completely inelastic collision, so only momentum will be conserved. So momentum conservation will be show that after collision, so this is the condition before collision. Now we can say that what will happen after collision. So as per as momentum conservation law, whatever the before should be after collision. Let us consider that velocity b or indicated by f after collision. So we can now say that after collision the new velocity that would be, that is m1 plus m2 into vf, that is final velocity of objects. Now if we compare that and we get the velocity vf as a subject, what we will get, we can say that here it will be m1 over m1 plus m2 into v1i. So this will be the condition for the relation between final velocity and initial velocity. Now it is also very well known that kinetic energy will also have some relation. That relation can be considered like that the loss in kinetic energy. We can say that the loss in kinetic energy is given by, that is delta k obviously initial kinetic energy will be 1 half m1 v1 I square. Now this is obvious because initially we considered that the object 2 is stationary. Now due to the loss of energy we can say that after collision it will be 1 by 2 m1 plus m2 into vf square. Now we can replace the value of vf in place of this, so we can get the equation that is equals to 1 by 2 m1 v1 I square minus 1 by 2 m1 plus m2. Now in place of v1 f square I can put that is m1 square over m1 plus m2 whole square into vf square. Sorry, it can be written as v1 I square. So here it would be v1 I square. So we have converted the equation into the form of I. Now when we simplify this term we can say that 1 m1 plus m2 and this 1 m1 plus m2 will be cancelled out, and so we will get 1 by 2 m1 v1 I square minus 1 by 2 m1 square over m1 plus m2 into v1 I square. Now taking v1 I1 square as a common, we can get 1 by 2 m1 minus m1 square over m1 plus m2, and here we can say this is v1 I square. So when we simplify this term also we get the answer, that is m1 is also common in both, so I can take it also as a common. So I can put 1 by 2 m1, here it will be 1 minus m1 over m1 plus m2. So if I simplify this term, what I will get, that is by simplifying it I can have a simple term, that is 1 by 2 m1. Now after the simplification of the relation between this, only m2 will remain because m1 plus m2 as taking LCM minus m1 upon m1 plus m2 into v1 I square. So here we will have the answer, that is lost in kinetic energy, that is 1 by 2 m1. Here this m1 cancel out, so m1 into m2 upon m1 plus m2 into v1 I square. So this will be the part that is the lost in kinetic energy. Now this was the case in which we consider inelastic collision. Now let us consider the case that is elastic collision. So now what will happen in the case of elastic collision? So if we say that elastic collision, if we consider, then what will happen? So in the case of elastic collision, we can have initially. Do understand, first we have considered the inelastic collision. That means in that case we have taken that is completely inelastic collision, but right now we are taking elastic collision. So when we are taking the case that is elastic collision, we know that the energy conservation, that momentum conservation law and kinetic energy both will be followed. Now to follow that both condition, now what we can write here. So here it is clear that suppose, as we have explained in the previous case, the condition is same for the ground level. Let us consider the ball 1 is moving with velocity v1I. Ball 2 is say stationary, so v2 is 0, but this is before collision. Now as per as momentum conservation law, what will after? So after condition is explained in the next figure. We can say that here this becomes v1f, and at the same time this ball 2 or the object 2 will also have some velocity, that will be v2f. Now we can say that for the condition of momentum conservation, we consider with the same thing, that is theta 1 equals to theta 2 equals to 0. So here that means both are moving in the same direction. If we take theta 1 equal to theta 2 to be a 0, then we can say that momentum that is before collision, that will be equals to the after collision. So the momentum remains the same before and after collision. We say before collision, that is only object 1 is moving, so it will be m1 v1I. Here object 2 is stationary before collision. Now after collision, this will be m1 v1f plus m2 v2f. So this would be the condition. Now we can take square in both the sides from the equation of kinetic energy. So as far as that, this is momentum conservation law, and now we will consider the kinetic energy. So what will be kinetic energy? That is 1 half m1 v1 I square is equals to 1 by 2 m2, sorry, here also it will remain for object 1. So object 1, it will remain as it is, m1 v1 f square plus 1 by 2 m2 v2 f square. If we are taking 1 half common in both the direction, then we can put m1 v1 I square is equals to m1 v1 f square plus m2 v2 f square. Now from equation 6.24 and 6.25, as per as textbook, we can say that this is our above equation, that is equation number 1, and this is your equation number 2. We have to solve this equation and we can get the result from solution as very clearly that what we can get here if we subtract them from each other, then we will have a simple relation between m1 v1i and m2 v2i. Now how to get that relation over here? So first of all, what we will do, we will take the similar terms one side and then we simplify the other term as it is required. That means we know that here we have the kinetic energy conservation, that is before and after collision. So if we solve these two equations, we will have the condition that is m1 v1i, as it is common in both the way. I will have that is v2f minus v1i from equation 1 and 2. That means if this is equation 1, if this is our equation 2, then we can have the relation in a similar manner, that is equals to m1 v1f v2f minus v1f. So here we can cancel out the m2 part by just multiplying them or simplifying them in the term of multiplying equation 1 with 2f and then taking the subtraction between them. I will like to explain you this term, that how this term comes into the picture. So this is interesting one. What we need to do, we need to multiply equation 1. So multiply equation 1 by v2f and then subtract it from equation 2 and then subtract. So subtract with 2. So if we multiply first, we will get m1 v1i into v2f is equals to m1 v1f into v2f plus m2 v2f square, then equation 2, that is m1 v1i square is equals to m1 v1f square plus m2 v2f square. Taking subtraction, that means minus minus minus, we can have this term cancel out and what is remaining, that is m1 v1i. So here I can say v2f minus v1i, that is the first part of the yellow term. Now this is equals to, again, that is taking m1 v1f as a common, we will have this is V2F minus V1F. So this is the yellow part 2 over above. How it is obtained, it is explained in this portion. So I have just explained, that is not the necessary part. You can even omit this portion and remember the whole thing that is given in the textbook. So you can write it also directly, but for the explanation point of view and for the understanding point of view, I have explained this equation, that how it is obtained for us. So ultimately we have to remember the equation above. Now from this condition, what we need from that yellow portion equation, we can also simplify the equation in different manner, that we can write now, that is V2F that we have now, that is V2F into V1I minus V1F, V1I minus V1F is equals to V1I square minus V1F square. So I will leave it to you to solve. That is equals to, now if we simplify this term more, we can say that therefore that V2F into V1I minus V1F, I can simplify this part, that is V1I minus V1F into V1I plus V1F. Now V1I minus V1F is cancelled in both the equation again. So now what we will remaining and what we will get is the remaining part, that is V2F is equals to V1I plus V1F. So this is our another relation for the calculation point of view. Now if we put that above equation 1 with this equation number say 4, I would like to put this as equation 3, this as equation 3, and this as equation 4. Now we put them, and if we have substitution of equation number 1 in place of this value, we can convert our equation into that V2F into the form of V1I and V1F into the term of V1I. So that part I left for you to solve, and we can say that after this simplification we obtain that V1F is equals to M1 minus M2 over M1 plus M2 into V1I, and V2F is equals to 2 times M1 over M1 plus M2 into V1I. Now these are given as per as your textbook. Here I give this equation as a number 5 and this equation as number 6, which are your textbook equation number 6.27 and this as 6.26. So these are the ultimately result that we have obtained. I leave these two results to follow and try to solve it. This will be easy as we have done earlier. Now, what are the different cases for the above condition? Now in this case we have the interesting part over here, that the unknown velocity, that is v1f or v2f, are obtained here in the term of known velocities, that is v1i and m1 m2 values. Now we can go with the special case of our analysis and they are interesting also. So we will go with the special case. Now what is special cases? So first we consider that if this is our case 1, if both mass are equal, that is m1 m2 is equals to some common value, then what we will have, we can simply from equation 5 we can say that v1f will be 0. So from equation 5 we can have v1f equals to 0 and v2f that is equals to v1i. So if both the objects are of the same mass, then what will happen? Let us consider with the figure. This is object 1, this is object 2. This is initial condition. This is moving with v1i and this is stationary. Now what happens finally, that after collision, if this is the condition, then v1 becomes stationary and 2 starts moving with the same speed as it was having initial. So the velocity of 1 becomes the velocity of 2 after the collision. So if both masses are equal, then object 1, which is initially moving with speed v1i, will stop at final stage and the object which was stationary start moving with the velocity of the object of the speed 1. So here this is the interesting case. Now we will move with the second case, that what happens as it is in a case number 2, that if one mass dominates, that is either one of the mass, that is if suppose m2 is very much greater than m1, okay, then what will happen, that will be, that is v1f will almost equals to minus of v1i. That is obviously visible from our equation number 5, that if m2 dominates, then m1 can be negligible and in that case this will be the negative type of sum. Similarly, if we go with that velocity 2 term, then if m2 is major, it is in denominator and therefore the term will remain very small for the equation number 6. So from equation number 6 we can say that v2f becomes almost 0 0. Obviously if it is opposite condition, that is m1 is very much greater than m2. Then again we will go with the equation number 5, that if m1 is major, then what will happen? Then it is clear that m1 is major. Here v1f will be v1i. So for that v1f becomes v1i. But what about v2f? So v2f will also have 2 times of velocity, that is of v1i, because here we consider that m1 is a very higher, m2 is negligible, and therefore v2f in this case, that was earlier it was stationary, it becomes 2 times v1i. So these are the special cases of, that is, elastic and inelastic collision in one dimension.